Hello everyone. So this will be the start of a Calculus 2 series I'll be doing on this channel, and I'll just be doing problem solving for every chapter or like section in Calculus 2. And in this video, it's about cross sections. All right, so for the first problem, it's going to ask, the solid lies between planes perpendicular to the x-axis at x equals 0 and x equals 4. The cross section is perpendicular to the axis on the interval 0 less than or equal to x less than or equal to 4. Are squares whose diagonals run from the parabola y equals negative root x to y equals root x. So let's start off with drawing a graph. And it's very hard to draw a straight graph, so my apologies. But let's draw root x, and negative root x is like this. I didn't write any numbers, but generally this is the shape of root x and then negative root x. So what they're saying is the squares, they're diagonals. We have squares. So picture a square here, right? And it's like a 3D square. And then their diagonals run from the parabola to the other parabola, or rather from the first function to the other function. So we know the value of this distance. It's going to be x, root x minus negative root x. Because you're going from the top here to the bottom, and those are its diagonals. So what we can do is to find all the sides, because we need the area of the squared or the side squared. So in order to get the sides, we do a squared plus b squared equals c squared, which is Pythagorean's theorem. So since we have the hypotenuse here, because when you slice it in half, you're going to have a triangle. And we could look for the missing sides. But since it's a square, the sides are the same. So you could just say AA. So really we have 2a squared equals c squared. So we know c to be root x plus root x. So 2 root x. And now if we square c, so c squared will be 4x. So now we have 2a squared equals 4x. And now we could solve for a, divide 2 on both sides. And we get a squared equals 2x. And then we get a is equal to root 2x. Alright, so now I moved it a bit, the screen, because I didn't notice that was cut off, my bad. So now that we have one of the sides, well basically we have both of the sides. So now we could actually calculate the area. So we can do a is equal to root 2x squared. And that's going to give you 2x. So we want to find the volume. And in order to do that, we're going to have to integrate this. So let's erase this over here. We're going to do the integral from 0 to 4. And that's because they're saying the cross sections are on the interval 0 to 4. And now we're just going to do the area, which you already established to be 2x, and then add the depth, dx. So now we're going to get the answer of 2x squared over 2, which is just x squared. And we're going 0 to 4, so really it's just 16. And that should be your answer. Alright, so in this problem, the question asks, the base of a solid is the region between the curve y equals 2 root sine x and the interval 0 to pi on the x-axis. The cross-section perpendicular to the x-axis are A equilateral triangles with bases running from the x-axis to the curve as shown in the accompanying figure, and B squares with bases running from the x-axis to the curve. So let's start with A. So they give you the figure with they give you the 2D graph and they give you like the shape. I made a 3D graph, maybe if it helped like visualize it. We're doing equilateral triangles like that. And they're saying that the base runs from the x-axis to the curve. So for an equilateral triangle, remember this section, we need to know the area for a bunch of shapes. And equilateral triangle is another one. So for equilateral triangle, it's the same sides everywhere. And its area is going to be root 3 over 4a squared. And it's the sides are the same in everywhere. So since we know one side, we know that one side to be this base right here. So we know that the base is going from the x-axis to the curve. So to have the value of this distance, we could just do root sine x. I bet 2 root sine x minus, well, the x-axis is just y equals 0. So it's really just 2 root sine x. Now that we have this one base, we essentially have all the sides. So now we just do this. We just plug this into the formula. So now we have area is equal to root 3 over 4 times 2 root sine x squared, which is going to be 4 sine x. The 4's cancel, and you're left with root 3 sine x. Alright, so now that we have the area, all we really need to do is just integrate it to find the volume. So, we're the interval, they already give it to us, which is 0 to pi. We're going to 0 to pi, the limits. And now just plug in the area, so root 3 sine x dx. So now when you integrate this, you're going to get root 3 cos x going from 0 to pi. Remember, it's going to be negative cos x. Simplify down to root 3 minus, so what we did was cosine of pi, which is -1, and -1 times the -1 here. It makes it positive. So we're just left with root 3. And now we're going to subtract cosine of 0. Cosine of 0 is 1, so really just plus root 3 is minus minus. And you're left with 2 root 3. Alright, so for part 2 of the question, it's asking squares with bases running from the x-axis to the curve. So we're going to have squares now. And its base is this distance right here. So what we can do is a will be equal to the curve, which is 2 root sine x minus the x-axis y equals 0, so it's really just 2 root sine x. Since we have the base of the square now, we can find the area, which is the base squared. So a squared is equal to 4 sine x. In order to find the volume, we're just going to integrate it. And we're going from 0 to pi. 4 sine x dx. And we're going to have -4 cos x from 0 to pi. Cosine of pi is -1, so we have 4 minus cosine of 0 is 1 plus 4, and it'll get you 8. Clarify a little more on what a was. A was just the base, and since it's a square, all sides are the same. So what the base was also the other side, which is why we were able to do this. Alright, so now this question asks, the solid lies between planes perpendicular to the y-axis. At y equals 0 and y equals 2, the cross sections perpendicular to the y-axis are circular discs with diameters running from the y-axis to the parabola. So now they're not asking perpendicular to the x-axis, now it's the y-axis. Well, this basically means that we're going to integrate in terms of y, but let's start off with finding the area of the shape. So we know that the area will be pi r squared because it's a circular disc. And we know that the radius is half of its diameter. So 2r will be equal to d. Right, so now let's draw the graph. So what this graph looks like, first you can just do this. I would rewrite it personally. Honestly, you know what it looks like. You just draw it. Go ahead. Honestly, you don't even have to draw it because all you really need to do is just find the diameter by subtracting. But to make it a little more clear, I will. So we're doing the square root. So what this is root x over root 5, so plus or minus. So what I got from this is that this is the square root function, plus and minus. So it's saying that its diameter is running from the y-axis to the parabola. So this is the y-axis, right? So this is running to here, the circles, and this is the x-axis. So from the y-axis to the parabola, so we're gonna keep going from 0 to y equals 2. So we're going from here to here, basically. So 0 to 2. And its diameter. So we know the diameter is root 5y squared. Oop, that was a bad 2. Root 5y squared minus 0. Because this is the function, and this is the y-axis. So when you subtract that, you're going to get the diameter, since its diameters are running from the y-axis to the parabola. So now that we have its diameter, we can find the radius for the area. So now the radius is simply going to be d over 2. So 2r equals root 5y squared. So now r will be root 5 over 2y squared. So now that we have the radius, we could integrate it. So now we're going to get the area. So for the integral, we're going to go from 0 to 2. And we're going to plug in the area, which was pi, and put pi on the outside because it's a constant. And r squared, which will be root 5 over 2y squared. And we're squaring that. And we're integrating terms of dy. So when you simplify the integral, you're going to have pi, the integral from 0 to 2. We're going to simplify this. We're going to have 5 over 4 y to the 4th dy. And the simple integral, you just do y to the 5th over 5. And then the 5's cancel here. Find the outside. So 0 to... So really you have pi times 2 to the 5th, which would be 32 over 4. And minus 0 over 4, which is just 0. And 32 divided by 4 is 8, so you're left with 8 pi.